Good morning, everyone. Waking up, 8:30. Thanks for coming so early after a great night yesterday with the experts. My name is Yuri Diógenes. I'm a senior technical writer on the data center device enterprise services. I'm here with Josh and Tom.
I'm Tom Schinder. You might know me from my past life as the ISA TMG guy. I work with Yuri in the DDAC, which is essentially a Windows Server Information Experience Group, and we are on the solutions team.
And my name is Josh Adams. I'm a senior program manager in the PACE team. That's the partner and customer ecosystem team. And there we consider ourselves the nexus between the partner, the customer, and the product group. And I'll give another plug later. We try to combine all those together to help validate the next generation of Microsoft's products.
So today we are here to talk about architecting a cloud infrastructure, a practical design scenario. Tony and I, we are the architect track PMs for the architecture track. And throughout this whole week, you've probably seen some of our sessions where we describe many patterns and practice for designing cloud infrastructure. Today, we're going to expand a little bit on that by giving you a practical scenario for a very well-known company called Contoso. But it's really based on a true scenario, and we are going to access our servers in Redmond. That's why Josh put all together the lab, and the presentation pretty much is 80% demonstrations, because I think that is a great way to to wrap up the whole idea of building a cloud after 2 days of theory and patterns and everything. So we're going to start with a scenario definition, design decisions, and then we're going to go to implementation, where we are going to leverage some of the new capabilities on Windows Server 2012 R2, which is also a great thing, because Contoso, by the time that they start the project, it was not with R2, but now they can leverage some of those capabilities.
So we'll start with the scenario definition, which is essentially the current state and goals for Contoso. So Contoso is like most of us. They have a traditional infrastructure, and they kind of want to move toward the cloud. They've read about it, but they're a conservative organization. So they're trying to improve their operational practices. They've read about ITIL, and so they want to come up with a very planful and thoughtful cloud strategy. So they're not just going to go bursting into the cloud. They want to start by building a cloud infrastructure, which is essentially going to be the virtualization infrastructure on which they'll build their cloud services. They're not looking to revamp their IT organization. So they're going to start with sort of a small greenfield deployment where they're going to build out a private cloud infrastructure, the core networking, storage, and compute, and then they'll move forward where they'll enable the essential characteristics of cloud computing as defined by NIST. Their current frustrations, they've got a lot of problems that most companies have. It takes weeks for them to provision new resources to enable services for their customers. The divisions within their company are getting increasingly impatient. They're perceived by organizations within their company as being slow. And so what's happening is that these departments are starting to use credit card IT, where they're going to use where they're using public cloud services to stand up their stuff, which is very problematic for the company, because when you have credit card IT, you have problems with data governance and security and a whole host of issues that IT really doesn't want to have to answer for. So they've read the standards in the industry about cloud. They've got the conceptual background they need. They've read the PCRM by Microsoft, the private cloud reference model. They understand the problem domains, and they're getting an idea of what they need to do to enable the cloud. They've read NIST. They know the 5 essential characteristics of cloud computing, which I'm not going to go over again with you guys, because you probably heard them about 100 times already. And they understand that there's the opportunity for them to save money because they've read the cloud economics paper put out by Microsoft. They have some core requirements. They want to start by building the cloud infrastructure, the core network, storage, and compute infrastructure on which they will subsequently build an infrastructure as a service offering for their internal customers. Then they're going to bolt onto that effective virtualization capabilities that is going to use this infrastructure. And then they're going to have it as their goal to support generic stateful and stateless applications in their infrastructure as a service. So when I say generic, I mean we're not going to build out a cloud infrastructure that's going to support all the specific requirements for SharePoint, all the specific requirements for Exchange, but something where you can run generic services. So Contoso will keep their existing infrastructure where they have their siloed servers and deployments of their existing stateful applications, and their goal is for their infrastructure as a service to support these more generic stateful and stateless applications. So, Yuri, why don't you tell us about some of the design decisions that Contoso made?
So based on this initial assessment that they had to do on their infrastructure, some core requirements, and why they are moving to the cloud, because it's like Eduardo Kessner said yesterday, it's not only about moving to the cloud. Do you really need to move? What workloads you need to move? It's not going all the way through. You probably need to plan a little bit more. So the first thing you need to understand is what service you are going to offer to your internal tenants, to your consumer. And to do that, you probably need to categorize the services, and you need to understand the demand and which departments you are going to the cloud, because probably not all internal tenants are going to move immediately to a cloud infrastructure. So you need to plan ahead of that. For Contoso, what they did was they defined service classes, pretty much leveraging the same idea as Windows Azure, where you have computer instance based on size, small, medium, large, and extra large. That way, their consumers can choose which compute resource they're going to use based on those T-shirt size, let's put it this way, right? And then we have the service level, because as a cloud provider, we need to agree upon a SLA with our internal tenants. And for this particular scenario, we are using 99.5. And we need to define which consumers are going to migrate, as I said before. What are the business units within the company that will migrate to this new infrastructure, and then determine which T-shirt size that we're going to use for that. The core diagram or the core setup for what we are going to demonstrate today is based upon this diagram, which Josh will go over in more details, because he has an expansion of this diagram before he starts his demonstration. But basically, we have a file server and a Hyper-V server. Clustered. Both are clustered. And we do have also a 10 gigabit Ethernet teaming for the infrastructure network, as you can see there. We could use, optionally, a 10 gig RDMA NIC for the cluster and storage and live migration traffic. We said optional because this is really not mandatory for Contoso, but for our demonstration, actually, Josh is going to use RDMA and leverage some of the new capabilities on there as well. We do have 1 or 10 gig Ethernet network for the tenant, and when we say 1 or 10, it's really based upon the needs for the tenant network. If 1 gig is enough for you, according to your baseline and everything, it should be enough. If not, you put a 10 gig network in NIC teaming as well, LBFO, specifically for the tenant network. We're going to have the file server connected to a JBOD via SAS HBA card. So that's the core design for our setup that we're going to do on the demonstration that Contoso actually is using. Now, since Tony and I have been working with security for the past 10, 15 years probably, we try to incorporate in many of the design practices for the documents that we write in our team and the solutions that we put together, some security stuff on it, because at the end of the day, you do not want to think about security only when you finish your project. At that point, you are full of breaches already. So the idea is to think about security as soon as you start planning and you start putting together the cloud infrastructure, because we are only covering the cloud infrastructure. You still have the management layer, you still have a bunch of other layers on top of that. So if you think about security in depth from this perspective, you should review each one of those layers. So you have your cloud design infrastructure. What about the virtual and physical compute aspects? You need to have security considerations for the virtual compute and to the physical compute as well. It's not only about the VMs that will be protected or isolated. You need to think about the host. So how are you going to protect the host itself from a piece of malware? So some operator go to the data center and hook up a piece of malware on that host and try to boot from that server. Are you going to use secure boot? Which capabilities are you going to use? Same thing for the physical network itself. Okay, it's not only talking about leveraging Windows capabilities to protect your network, but if your switch goes down and you have no redundancy, that's a problem. It doesn't really matter if you use DHCP guard or ARP protection on the Hyper-V virtual switch, but your physical switch has no protection. So you need to plan also the security of your physical infrastructure. So for virtual and physical compute resource, we have just some examples of things that you can leverage, update virtual machines before they are deployed to a production environment. Always test this before you deploy. The same idea that Eduardo was talking about yesterday on his presentation, to have the validation environment, enable integration services on the VMs, and like Guyana said yesterday, use RBAC, role-based access control. It's very important in this scenario. And for each one of the assessments that you do, make sure to detect and document all the vulnerabilities because they will be there, okay? And make sure to do a risk level assessment when you discover those vulnerabilities because sometimes you're not going to fix everything. And that's the reality. There are some vulnerabilities that you know it is there, but the cost to fix those vulnerabilities on the infrastructure is so high, and the likelihood that they will be exploited is so low that you probably will say, well, this is priority 2. We can deploy the cloud infrastructure with this, and we can live with that because the likelihood is minimal and not a very problem right now. Identify vulnerabilities that have not been remediated and take actions, or at least have a plan of action to remediate in the future. So for every single assessment that you do, make sure that you finish the assessment covering those 3 core aspects. For the physical network, the same thing. Use secure access control. Then you can use port echo on Hyper-V. That's just an example of something that can help you with secure access control. For traffic control, you can leverage some features on Hyper-V as well, like Hyper-V QoS. And again, after you finish all the assessment, make sure to cover all the 3 options that we have at the end here. That's why we are emphasizing for every single layer to go through this vulnerability assessment. Now, from the implementation perspective, we have something called DAO. What is that, Tom? What about DAO?
That's the data center abstraction layer. Has anybody here heard about the HAL? Does anybody remember the HAL? Yeah? What's it stand for? Exactly. So the HAL was a major advance, right? We didn't have to write specific drivers for each of our applications. We could just install our NT 3.51.
Nice.
And then install our apps. And so that was considered revolutionary at the time, this abstraction. So what is cloud about, really? Cloud is about abstracting the underlying infrastructure from the services that depend upon that infrastructure. So with Windows Server 2012 and now with Server 2012 R2, we are going to take that abstraction to the next level. And Josh is going to actually demonstrate this abstraction where we're going to abstract the network, compute, and storage even more so that ideally our services are completely oblivious and don't care. So this abstraction allows pieces of the infrastructure to croak at will and the services keep running.
And Contoso will also use, for this particular implementation, we're going to demonstrate that, something called faster live migration, which is a new capability in Windows Server 2012 R2. It's not only about faster live migration per se, it will be faster, but it's also about spending less time using resources so that you can be not only faster, but you can use less resources to not impact the tenants. So if you have a shared infrastructure, the last thing that you want to do is to compromise the performance of other tenants because you're doing a live migration or something like that. So we improved the live migration using a set of new capabilities that we accomplished by using live migration multi-channel and live migration RDMA support. And during the presentation, during the demonstration that we are going to do later on, Josh is going to emphasize exactly in which point of time we are leveraging those capabilities. What about QoS, Josh?
Well, in Windows Server 2012, we introduced network QoS, which is a great part of the story, but there's one piece that we omitted, and that was storage QoS. And now with Windows Server 2012 R2, we've actually introduced storage QoS, kind of completing the picture of having the service provider have total control over their tenants.
And we're going to demonstrate that using IOPS, right?
Correct, yeah, we have some demos set up. We can show you that in depth.
Let's do it now.
All right, let's go.
All right.
So good morning, everyone. Great turnout, great to see everybody. And when Tom and Ira came to me and they asked me to do some demos, they thought at this point on Wednesday, you guys would have lots of slides in theory and want to see maybe some more hands-on demos. Is that the case? We could switch back to a lot of slides.
You want to go back to the PowerPoint?
What do you guys think? Yeah, demos.
Yes. Yeah.
Hey, we all love demos. So quickly, before I kind of get into the demos, I kind of want to show you the environment that actually I built. And the URL of the EEC, I mentioned that. I work at the Enterprise Engineering Center up in the upper right-hand corner. Quick plug, if any of you guys want more details about what we do, feel free to visit the website, send me an email. My email address is josha@microsoft.com. So typically at the EEC, we build customer-like environments either directly with the customer or using feedback from a customer, and then install the latest and greatest software and try to validate, find the gaps, and feed that information back to the product group. So this is an environment that I've been working on the last couple weeks. We have...
Josh.
I don't need...
The pointer?
No, pointer? Sure. So in Windows Server 2012, we really enabled the concept of scale units of compute, storage, and network. And in Windows Server 2012 R2, we've extended that. So this is a logical diagram of what's over here physically. So physically, we have 8 compute nodes. We've got 1 management node. And we have a scale-out file server cluster with two servers connected to 2 JBODs. What that allows us to do is start from the ground up with storage. So in Server 2012, we introduced the concept of storage spaces. In R2, we've added an additional layer here. So inside your virtual disk, there's the concept of storage tiering. Now, storage tiering is one of those scenarios that I just simply love, because it combines the performance of SSDs with the low cost of HDDs. And so we'll demonstrate that. And with that, too, the Spaces team, the product group, actually enabled a write cache now in the Spaces stack. So now we actually have a write cache built into your virtual disk. So this layer is new for R2. And on top of that, we can add a scale-out file server cluster, add our CSVs, add some shares, and then we can connect that to our compute scale-out unit, which is the Hyper-V cluster, connected via SMB3. Now, that was, again, introduced, revved in Windows Server 2012. But in R2, we've added a few more things in SMB3 stack to make it even more resilient, more dynamic. One of them is load balancing. Now we actually load balance across the scale-out file server nodes more efficiently. And there's some improvements in SMB Direct RDMA that actually gives you even more performance. Up in the Hyper-V cluster, and again, some of these features, there's a ton of great new scenarios and features. I'm just mentioning the ones that we're going to talk about today specifically and the ones that implemented in this environment. We've had live migration for a while now, but again, in 2012 R2, we've added some new functionality that allows you to take advantage of this SMB3 stack, and we've added storage QoS, like was mentioned previously, to complement the existing network QoS. So it really gives the service provider, again, a holistic management view of their tenant VM to really control what they do not do. So let's jump in to kind of go through what the service provider might be building out. So let's switch over to, okay, I'm actually going to go to, so this is kind of an outline. I threw it together. This presentation is going to be given in Europe as well, and I'm not going to be there, but I actually have the step-by-step guide for Yuri so he can actually run these demos himself. So real quick, we talked about the physical environment. We'll go over here to PowerShell. Now, this isn't a PowerShell talk of how to use it, but I do want to, when I see demos, a lot of times people hit go on the PowerShell and you don't know what exactly commands were being invoked. So I want to touch just briefly on some of the commands that we'll be running here. So this is just a quick script we run that actually interrogates all our nodes so I can really quickly see what's up and what's down. We dynamically add some node properties, and I commented some of these out as they weren't relevant for this talk. But as a network administrator and IT pro, I can really quickly see all my nodes' IPs, if they're alive, what versions, etc. And I noticed that one node is down. Now, we talked about the doll. And again, I love storage spaces, all the great features, but the doll is actually probably on parity with me as one of my favorite features in R2. Because we have the traditional setup at the EEC. We've got the IT pros. We have a dedicated network team, dedicated storage team. So if I want something done networking, I have to go talk to somebody else. And not that I don't like talking to somebody else. Love that. But with the DAL, I can now actually do most of that myself. So I notice that 7 is down, and so I actually have that machine on KVM, which I'll bring over here. And I notice that all the network connectivity is gone. Everything's unplugged. So normally I'd have to call in the network team. But now with the abstraction of the DAL, with an OMI-enabled switch, I can directly interrogate the switch that is running in my environment to kind of see what's going on.
So you're going to configure the switch through PowerShell.
Exactly. So now inbox, you can configure switches that support OMI via the data center abstraction layer. So all you need is the IP of the switch, the port that you're going to connect to, some credentials, and you're good to go. So with this, the meat of this, the PowerShell commandlets, that this, you actually set up an instance, give it a class name. We're going to search for the ports that machine is connected to. And if they're down, we're going to toggle them back on. So let's run this. And while that's running, let's go back over here and see if these interfaces actually come up. Let me move that over here. Okay, so with the outputs, so we actually got some information from the switch itself, interrogated the manufacturer, the model. You can actually see the OS. You can actually, from all this, you can do inbox. The ports did happen to be down. And let's go back here and see. Oh, here we go. So now they're back up.
Look at that.
So that was the problem. That's why those two, that server didn't show up in my PowerShell query. But something, I don't trust this machine. It was down. I wanted to flatten it and bring it back up into my cluster.
Now, let me ask you something. Being a security paranoid guy,
Sure.
How's this communication done? Is it encrypted?
Yeah, so there's lots of options. In this, I actually used SSL. So if we go down here, you can see the session that I set up. So I use the SSL.
Yes, yep.
Okay.
So there's lots of different options. You can configure this. But in this case, I use SSL. Definitely don't want things being sniffed on the wire. So not only does the DAL allow you to talk to TORs, top-of-rack switches that support OMI, you can also now talk to BMCs, your basement management controller. Again, that functionality existed third-party, but now it's been brought into Windows under the umbrella of the data center abstraction layer. So I can switch to my DAL BMC commandlets, and now I can directly query the device. Let's see what exactly is going on with this machine. So I can switch back over. Okay, so now we know it's on the network. What I want to do, I want to restart it, but I want to set the boot order. I want to change that to a first-time boot of network, and I'm going to have it come up and actually image it via WDS.
So you do this everything remotely?
Yep.
With no need to talk with the networking guy?
Exactly. It's all now under my purview.
Thanks to the DAO.
Exactly. So let's run this script, and we'll talk about what exactly it's doing. So again, right now I just interrogated the BMC of the local server. There's lots of information you can pull, serial numbers, BIOS information, and now I'm actually going to flip this switch to true So that'll actually come down here. I'm going to set a one-time boot to network, and then I'm going to restart it. So if I run this, and I come back over here, okay, we've lost it because now it's restarting. So while that's restarting.
So that's a KVM, right?
Yeah, so this is KVM, totally out of bound. This is just so I can kind of see where it is. It takes about 2 minutes to reboot. We'll keep an eye on that, but I was going to show you that even while it's down now, powered off, I can actually still interrogate the server. So that's the great thing about talking to your servers via BMC. Even if they're powered off, you can still interrogate them, see how they're configured, and turn them on if needed. So if I turn this back to false, just so we can look at it. And there are a few nuances with, so what the doll is actually doing for BMCs, you have two options. You can talk IPMI to your BMCs, or you can talk WSMAN. Now, the vendor is, IPMI is very vendor specific, and each vendor implements it somewhat differently. So there's some nuances. So if you notice, I tried to connect 2 times, didn't get there, connected the 3rd time, and it came up. So IPMI v2, it's somewhat sensitive to the vendor's implementation. So Dell has a few nuances. One is if I set the boot order to have a one-time boot of network and I don't reboot in 30 seconds, that boot order will revert back. It's kind of a gotcha we discovered in doing this demo. Again, all the stuff we documented, blogged about, so you guys don't have to worry about it. Let's go back over here. So now configured the memory. Still booting. So now, while that's still booting, there's a few features I want to talk to you about in WDS. WDS, you've always kind of managed it via the WDS util exec, and now that in Windows Server 2012 R2, they actually have some commandlets that you can actually manage your server. So let's look at those real quick. So these are all the new commandlets introduced in R2 that allow you to manage your WDS deployment. If you look at this list, almost all of them are about the client management. They're not about configuring the server itself. Those will probably come at a later date. So if you want to do things like actually force all clients, unknown clients, to receive a PXE image, that still has to be done through the WDS util. But this really allows you now to manage your clients. And we'll demonstrate that with this once the server's up. And it looks like it's just about getting there. It's got 64 gigs of RAM. It takes, like I said, about 2 minutes to boot. And we're going to use the approve client commandlets. So we give it the request ID, which will come up automatically because the PXE server is set to respond to unknown clients. Give it a name and then an unattend file, and we should be good to go. So it should be just about ready. Usually on this one there's 4 dots. Let's get it. Then we can approve it. And this one is, okay, there we go. So it's going to boot automatically into WDS. And there, as expected, we have the pending ID of 1. And the reason it's 1 because this is the first time since the restart of the server that a request has come in. So I'm going to go ahead and run this script, which will then, this is a new feature in R2. Okay, so we approve that client. So now if I go back and actually see it, it's going to start as PXE boot.
So you have to approve first before it boots?
The way I have it set up, yes, exactly. You could have them automatically approved if you want, but this way it allows.
That way you can actually protect, right?
You can protect. You can name it, and you can assign a customized XML unattend file. So we'll let that go. So this will be brought back up into our environment, and our cluster will be complete. Our compute cluster will be complete again. Okay, let's swing over to. Okay, now we're going to talk a little bit about the Hyper-V. So in Hyper-V, ton of new features in Hyper-V. Hopefully some of you guys had a chance to talk about some of the new features and scenarios coming in R2. We're going to create a new VM here in our cluster, highly available. So just so you can see a few of the new nuances and options you have in R2. Okay, let's create a new virtual machine. We're doing this through the failover cluster manager. Pick a node, and you'll see real quickly. Okay, we'll name it TechEd VM01. And so I changed the defaults. In my default, I'm going to store the VHDX file on an SMB share. And now here's one of the first changes, Gen 1 or Gen 2. Now Gen 2 is fantastic because it allows you, one, there's no legacy NICs. You can boot directly from a standard NIC. Your boot device can be SCSI rather than IDE, so you get all the perf. And you can also do secure boot, which provides additional security. So we're going to go hit Gen 2. And the one kind of gotcha is, so the BIOS is UEFI, so your unattend file has to be a little bit different, mainly in the disk that you set up. So when we actually use WS to approve this, we'll use a different unattend file. And so I'm going to use this VM for live migration. So I'm going to give it 32 gigs of RAM just so the live migration takes an appreciable amount of time that we can actually look at some deltas. Because on our network, we actually do have, we have two 40-gig RDMA-enabled NICs. So things tend to happen pretty fast. So we use that. We'll connect it to the management network, so we actually get access to our WDS server. Those are all defaults. And now, with Gen 1 VMs, if I were to click this, it would go ahead and add a legacy NIC to allow me to PXE boot. In Gen 2, I can PXE boot directly from the standard NIC, so all it's going to do now is switching the boot order in the VM to do PXE first. So next, and finish. So the key takeaway there was that Gen 2 VMs. Oh, that's okay. I think it must already have that name. We'll go 3. So we'll just go back. Okay. Lots of different demos. Okay. All right. So that's good. It's creating the VHDX file on the back end storage server, storage cluster. Okay,
And that's on a CSV, right?
Yep, that's on a CSV. So going back to our diagram, so that actually we created right here on the share over to leverage the SMB3 improvements. Okay. And now let's go on and let's turn that on. And again, so this is connected to our management network with the WS server. So we connected that again. So this should come up just like we did the physical host. This VM should come up just like the physical host and actually get a PXE request. And we'd have to approve it just like before. Okay, so there we go. And it looks a little different before because this is UEFI versus the standard BIOS in Gen 1. Okay. So
are there any enhancements in this console? Anything new that we would really love?
You would love this, but to get those enhancements, which we'll talk about later, is you have to have the OS installed. Okay. So right now, at this juncture, we don't quite have that.
Okay.
But hold that thought.
All right.
I know, it is exciting.
I just couldn't hold.
Okay, so we talked about some live migration enhancements. So I wanted to go ahead and demonstrate some of those features. So if you actually go into your Hyper-V manager, you can actually set your live migration settings. Now in 2012, there weren't really too many options, but now in 2012 R2, there's some additional options. Now, this top one, TCP/IP, basically that's what you're going to get in 2012. That uses the standard algorithm, standard TCP/IP protocols. A new feature we added in R2 was compression. So what you're actually doing, you're compressing the bits before you put them on the wire. So you're gaining network bandwidth, but what you're losing is CPU cycles. So you're trading one for the other. Because it obviously takes more CPU cycles to compress that, then you free up network bandwidth. So compression is very valuable to use, but again, it's like everything, try it in your lab first. Make sure you have the free CPU cycles to spare before you actually use it. And then SMB, if you have that SMB3 network, like we have in our lab, you definitely want to leverage that. Because SMB3 gives you the multi-channel by default if you have multiple pathways. And if you have RDMA-enabled NICs, you get that SMB Direct. And SMB Direct is that offload technology that really lowers the CPU utilization, improves performance, and the drivers that are coming in R2 even take that performance to the next level. So highly recommended if you have that infrastructure, use it.
That's the default option, right?
No, by default, you're going to actually have TCP/IP.
TCP?
Yep, it's going to default to that. Because it doesn't know if you have SMB, so as an administrator, you need to go in there and set that up. And so let's go ahead and live migrate that machine we just created. Okay, so I have a script that does that. And most of these scripts I'm running from a management server. That's the great thing about PowerShell. You don't have to usually be on the servers themselves to run them. You can run them all remotely. So we'll go to this live migration demo. Okay, I need to change the name of this. So this is the name of the machine I want to live migrate. TechEd VM 03. Okay, talk about real quick what this does. There's a little bit of syntactic glue in this, because what I'm actually doing is performing the live migration, collecting performance counters on both the sender and the receiver, and then reporting that back. And so there's more verbiage here than really there should be. But really, this move cluster virtual machine role, that's really the meat of it and what type of live migration. But before that, I run a set VM host, and here's the new option, the virtual machine migration performance option. So first I set it to TCP/IP. That's the standard Windows Server 2012. Then I go ahead and do the same thing with compression. And then I do the exact same test I do with SMB. So let me run this. I can talk a little more as it takes. Okay. That isn't impressive, is it? Okay. Let's go back here to my cluster.
Oh, it did.
Yeah.
What is it doing?
Yeah, so it's actually on 4. So that's okay. That was I fooled it. So I want to starting node is 4, finish node. Sure, we'll do 1. All right, let's start that again. It should. Okay,
there.
A little better there. Okay, so the first. Oh.
Red is not good. Red.
Yeah, red is not good. I'm glad this isn't taped. On the audio, everything is working perfectly. Okay. Let me go back.
Just remember, it's a demo. It's always going to happen.
Yeah, live demo.
Yeah, live demo.
This isn't just.
Not a video.
Okay. Yeah.
Is
Yeah,
it case sensitive?
let's try the real trick. It shouldn't be, but let's. Okay. Might be. Now this is actually. I'll have to skip that for a minute. Okay. So I'll talk through the results, which you didn't quite see. So the TCP, that typically takes about 50 seconds to transfer that 32 gig of in memory. And the CPU is about typically 20-25% on both nodes. On the second one, when we actually switch it to compression, the results, the savings I was getting were only about probably 20 to 30% better. Now, you can get to, they say, up to 50% with compression. But I was seeing in my lab about 25%. But my CPU was almost doubled. So I was seeing about 50% CPU. So again, we're exchanging the network, packets for CPU cycles. So again, it really depends on your lab and if you have the CPU cycles to spare. And then kind of the coup de grace was with SMB Direct. It was about 25% faster than compression, which again was compression faster than TCP. But the CPU is right around 5-6%, negligible. Again, so that really was where the feature shines, is when you can leverage your SMB3 stack. Going back here, and that's again one of the main primary improvements in live migration in R2 is being able to leverage that. Okay, so we talked about live migration. So now let's talk about some of the storage quas enhancements. Now we talked about network quas earlier on. Again, that was introduced in Server 2012. In R2, we have the storage quas. So let's go over here and do that. So I have a VM already running the storage demo. Should be already connected to that. And I have Iometer installed. And it's just going to do, it just has a 50% read, 50% write workload, 4K writes, targeting a VHDX that's actually placed on an SMB share. So let's go ahead and start that up. to get some perfmon data. We'll save the results to the desktop. And so right now, we have the total IOPS, we've got 1,000. Reds are reads, about double the writes. And one nuance I want to talk about here. So with the storage tiering, I was able to allocate a certain percentage of my SSDs and a certain percentage of my HDDs on the same volume. And now, by default, dynamically, there's a concept of heat. In any hot files, the tiering engine will automatically move to the SSD. And vice versa, any files that are kind of old and stale will move back. Now, there's a concept of pinning. Say I want one file to be pinned to one tier or the other, I can do that as well. And with the right cache, with the SSD tier, because now we have the high-performance media, there's actually a space, too, that storage spaces will write directly to there and then flush later to disk. So the tiering enables that as well. So let's go back over here. Okay. So here's our workloads running, typical client VM workload. And for whatever reason, this client, they've been really good to us as a service provider, but they haven't been paying their bills lately. So we want to just give them a message. We're tired of sending emails. And so we're going to go into the VM itself, and we're going to throttle them back a little bit. So we can actually go to the hard drive in question, advanced features, and now here's the new checkbox, enable storage QoS. And so we're going to cap them at, well, they were at 1,200. They should be able to feel that one. But after we hit apply, we feel, well, maybe that's a little aggressive. So we'll go back up. Okay, we'll say 400. Okay.
So you're going to cap this VM at 400?
Yeah, 400. Okay, let's go back over to the VM itself. Okay. Oh. So now you can see the two tiers. So that I wanted to demonstrate that because storage QoS, it's dynamic and real time with negligible impact to the tenant itself. So the first thing I did 200. Instantly the IOPS dropped to 200. And then I went to 400, slight spike, and now they're settling right at 400.
So this solves the noisy neighbor problem in a cloud
exactly.
infrastructure.
Yep. So now one VM, you can make sure it doesn't hog all your valuable disk resources. Okay, so they got the message. They sent in the bill, got the check. So we'll go back, and let's turn it back up. We'll uncap it. Okay. So again, that's a property of the disk itself. Uncheck that. Hit OK. Now we go back and see in real time, right back to where they were. So now they're enjoying what they had before. But now they decided, well, they even like more performance. And so right now, we have them pinned to the HDD tier. So let's go over here. If we go into, I'm going to go to my storage cluster. Okay.
So right now, this VM is pinned to a spinning disk.
Exactly,
right.
To the spinning tier.
Spinning tier. Okay.
Yeah, so let's go ahead. And so there's most of all the tiering management in R2 you're going to have to do via PowerShell. But the commandlets are fairly intuitive to work through. Here we're going to get some storage tiers. We're going to interrogate the file. So this is actually the file, the VHDX that workload is writing to, the iometer. So let's run this, and actually just to verify where that file actually lives. Okay. So the current state, so here's the tier that it's on. And I say no cache because what happened was when I first created this demo, and I created a standard tiered virtual disk, by default, Spaces will create if you create tiering, it'll create a 1 gig allocated space for your write cache. And the write cache works very well. In fact, so well, in fact, that this demo, when I actually pin it to the SDD, it was like it never moved since all the writes were happening already on the SSDs because of the write cache. So I had to kind of synthesize, because I only have one workload, a storage tier without that write cache. So I actually created a new virtual disk with 0 write cache just for this demo. So that's why the name of this is tiered VHD, no cache. Okay, so here's actually the file size of the VHD, and we can see that it's completely on the tier. And if you switch back to the performance of the iometer. Okay. So this 10 is cruising along, roughly about 1,000. So now let's go ahead and we can pin it. Let's go ahead and move it to the SSD tier. Okay, so we're going to move pin file. Okay. So first we'll interrogate the current state. It's on the spinning media. Desired state. Okay. Oh, that's this one. Okay. True. Try that again. Okay. Current state, HDD tier. Desired state is the SSD. And the tiering engine actually lives within defrag. So by default, every 6 hours, that tiering engine will analyze the heat and move files every 6 hours. And again, that's all adjustable. But if you want to pin a file and you want to do it right away, there's a new option in defrag, which is this whack G.
And why you are using the GUID? Because of the volume?
Oh, okay. So yeah, so that's the question was, why am I using this big, long volume GUID? And the reason is, so we're actually, this demo isn't just on a simple space or a simple disk. This is actually a clustered volume. So there have been some other demos, I think 2 other demos about tiered spaces at TechEd. None of them have actually been on a clustered volume. So using cluster volume right now, you have to actually use the tool mount vol to get the full path.
Okay.
So it's just
So you
more
have
of
to use a tool first to extract this and then use it.
Exactly. So my script here actually runs this mount vol command.
Okay.
And you actually point it to the volume in question to actually get that GUID.
So in this demo, you forced the tiering.
Exactly.
But in practice, it would be auto tiering.
Either or. I mean, say a client wanted to guarantee that their file was always on the SSD tier.
Okay.
So in that case, you'd want to make sure, so that if that tenant is going to pay you for that level of service, you have the option to always pin their files on the SSD tier.
All right.
And by default, it'll move things automatically. But again, if you wanted to pin, or vice versa, say somebody is not paying for that level of performance, they have say a silver package. You could then pin it to the spinning media. So if we go back over to the cluster and look at iometer, we should see an increase in performance. And look at that.
Look at that.
So here's where we were originally capped, and now we've more than almost doubled our IOPS. And again, it's all relative. On some demos, you can see a 10x improvement. Our spinning media here are actually pretty good drives, but you can see with no impact to the VM. Again, the VM is still being accessed, still being used. We can move that back and forth. So we can actually, we can actually switch back and we'll say, well, that gold package is too expensive for this customer, so they want to be moved back. So let's go ahead and move it back to the spinning media. So again, so it was on the SSD tier. We want the HDD tier. We invoke the tiering engine via defrag, and it'll actually run it. And what it's actually doing here is actually copying those bytes. And so right now, you can interrogate the file size and the file size on the tier. And so I'm just writing to this progress.
Now is it moving the file from one virtual disk to another?
No. So tiers exist within a virtual disk. So it's still in the same virtual disk, still hosted by the same CSV share. But within the virtual disk, where that physically where the file lies, that's moving.
Okay.
So it's being copied on the block level from, in this case, the SSD back to the HDD tier.
All right.
While you're doing this, is there any performance hit at all on the virtual system?
Great question. So the question was, is there a performance hit while you're actually moving the file? Because there's a finite amount of time that it takes to move the file. And to answer your question, there is. Now, the build I'm running, and actually, I think you can kind of see it. So right now, the move is totally done. We were up here, and this is actually when the move was taking place. So there's a slight depression in IOPS during the move. Now, that's been improved in later builds. I'm not sure what percentage, but there is a tangible amount of performance hit, but I don't think it's going to be anything that's going to cause any kind of design decisions. But yeah, during that move, even though the file can still be used, still be accessed, slight performance hit? Yeah, good question. So now this client's back on the HDD tier, low-cost plan, and spinning along just like they were before. So now I want to talk a little bit about creating these virtual disks. In Windows Server 2012, that was the first time Spaces story was introduced, and now when you create virtual disks with tiers, it becomes a little bit more complicated because now you actually create your tiers and then assign those tiers to the virtual disk. And so this script, I've already created the virtual disk, but if it hadn't existed, this is actually the script I used to create the virtual disk. So I thought it might be insightful to kind of go through it. So the first thing you do, you create these storage tiers. New storage tier, new commandlet R2, give it some names, and assign it media types. 2 types of media supported, SSDs and HDDs. And then here's really the meat of this script is the new virtual disk. A lot of it looks the same, but now actually there's a new switch, a new parameter for storage tiers. And so I actually pass in those 2 tiers that I created previously, and then I specify the sizes. So I don't have to use the max, even though I have, in this configuration, terabytes of SSDs, I don't have to use all that for my tiers. I can use just a percentage of it. And at the end, too, here's another, this is the write cache. So again, with a tiered space, you have the option to create that write cache. Highly recommended, works extremely well, except when you're trying to give demos and actually show performance improvements going from spinning to SSDs.
So the write cache is kept on the SSD.
Exactly.
If I don't have SSDs, will I be able to maintain a write cache?
You will not on the spaces level. So there's lots of caching within Windows itself. Windows has its own cache manager. We're using CSVs. So in Windows Server 2012, there's actually a read cache on the CSV layer. And now, again, with R2, now there's that write cache to kind of complement that CSV cache. So the story is a ton of improvements on your storage stack. Okay, so then you actually dynamically specify your write cache. And by default, if the space is there, it'll try to do 1 gig. But again, I had to zero it out. And then you do the standard provisioning, add it to the cluster disk to the cluster, and then add it to CSVs. And you can actually, so then, in this one actually, we even enabled dedupe. Now, I don't have a lot of files on this volume, but I wanted to show that in Windows Server 2012, we introduced a ton of great features and scenarios, but a lot of them didn't play nicely together. One of them happened to be dedupe and CSVs. And there were a lot of restrictions around spaces and what kind of spaces you can do and mirror spaces and provisioning. And the story of R2, it continues that was started in Windows Server 2012, but it allows all these features to play nicely together. And I'll make one notable exception in this deployment. You'll notice that I have, this is my hoster backend infrastructure network, which is RDMA enabled. Now, it didn't make the cut, but in Windows Server 2012 R2, you still cannot use LBFO, NIC teaming, and RDMA. So you kind of have a decision to make that if you want to use RDMA, you can actually team the NICs, which isn't that big of a deal because with SMB3, you actually get that multi-channel by default. So you actually do have that redundancy. But a lot of times, customers that kind of catches them off guard when they actually design it, that if they want RDMA, they can't use LBFO. But for the most part, the features that were introduced in 2012, the ones that didn't work together in R2, they work great together. Let's go ahead and run. We'll get the output of, okay, these are the disks. So without the write cache, and using PowerShell is the way you're going to manage your tiering. You can see the allocated size, the footprint on the pool, and the write cache. And this is actually the default virtual disk I made first. And here's the default write cache that I actually made, just about 1 gig. And then here's actually the tiers, too. So these are the tiers that are assigned to my no cache. So when you create a virtual disk and you want to use tiering, you got to remember you create your storage tiers first. And then you also have the option, if you use PowerShell, to set that write back cache. If you use the UI, it'll create the default write back cache, and there's no option to change that. Okay, so that. that was storage gouache, storage tiering. Now, Tom had mentioned some improvements in Hyper-V, or one in particular, as far as accessing the VM. And this one is actually kind of nice. So we'll go back to my cluster and actually connect to that VM. And so now say this disk I/O, I want to save these tests. I'm going to stop this test. And I want to get these results out of the VM. But the VM is on a totally separate network. It's isolated. All I want is this little CSV file. Well, now I can right-click, copy, go to a folder on my host, and paste. So now you actually have... And the way that's enabled, so it's actually on the Hyper-V level. So you can set that per Hyper-V. You go into your Hyper-V settings. It's called Enhanced Session Mode. So really what it's doing is creating an RDP connection to that Hyper-V, or to that VM. So not only do you get cut and paste clipboard, you get some redirection, and you also get better screen resolution. So that, again, a small little feature, but it really helps, again, complete the story that was started in Windows Server 2012. And so going back to kind of wrapping things up with the demos, with Server 2012 really allowed you to do is separate the compute, network, and storage, and have 3 unique, independent scaling units. And with R2, again, I'd say it over and over, but it extends that, so you still have the ability to scale independently your compute, network, and storage, but now it wraps a new management layer across everything, the DAL, and completes the picture of allowing all the different features to play better together, and basically new improvement enhancements across the entire stack, from storage to networking to compute. So that's...
Go back to this line.
What's that?
Go back to...
And we'll have, I'm sure, a lot of questions. We can take those after...
Next.
Oh, next. Oh.
So in conclusion, we started off with the scenario with Contoso was interested in expanding their capabilities and investigating cloud computing by starting off with a basic core infrastructure on which to create a future infrastructure as a service offering. So if you want to understand this scenario better, we have written a collection of documents called the Private Cloud Infrastructure Solution for Enterprise IT. And you will, if you do a search for that, or if you check our Twitter feed, you'll see it announced a lot. And it goes through all the details of the scenario, the design considerations that Contoso went through, which includes many of the features that are available that Josh showed you today, then a design guide that actually goes through all the design decisions that Contoso went through, sort of like the process that you would go through when designing your own private cloud infrastructure using the platform capabilities around storage, networking, and compute. Then we finish it off with an implementation guide where we actually show you how to build that core private cloud infrastructure using many of the techniques that Josh demonstrated today. And actually, Josh includes the PowerShell scripts up in the gallery to show you how to do it, too. We always want to use industry standards. Everything that Josh demonstrated is based on industry standards. We're not in the business of creating our own anymore unless we need to. And of course, security is a wrapper around the entire solution. Security is baked into the entire design process. We are going to rev the documentation I just told you about very soon, together with Josh, so that Windows Server 2012 R2 will be the platform on which you can build this private cloud infrastructure. Related content, some good demonstrations that are related to what we did today. We're currently working on a hybrid IT model where we'll connect this private cloud infrastructure to Azure infrastructure services, and that's a really exciting project, so keep your eyes open for that. If you want to talk to us about this or anything else, maybe TMG and ISA, UAG or Direct Access, Yuri and I will be at the CSI booth. Also, Yuri and I have published a book in the last couple of weeks called Windows Server 2012 Security from Endpoint, Edge, the Gateway, and Beyond. If you want to, if you already have the book, we'll sign it. If you want to buy it, we'll sign it. Resources, Channel 9, Microsoft Learning, MSDN. You've seen this many times here. Make sure to complete the evaluation so you can win a cool robot or a Best Buy card. And then scan this tag here if you want to evaluate us right away. So thank you very much. I enjoyed having you here. Go forth and prosper.
Any questions? You want to tell them?
Oh, questions. Right, we got plenty of time here. Wait, don't prosper yet.
We can definitely take things offline, but if there are any questions about any specific technology we showcased or architecture, storage tiering, live migration. Again, all the demos that on the scripts that I've used will be posted. It's going to be up on gallery, so it's easy to find and search.
All right, if you have any questions, you can come up here. We'll give you detailed answers.
Thank you.
Thank you.